So one problem with a stepwise selection is that if the number of predictors is too large, then it just simply we do not have enough computing power to examine all the possible models. So in the previous part of the lecture, we saw 10 variables and 1024 possible models for the best subset selection, right? But with 20 or 30 variables, it's just simply too many. So another issue is that with too many models to examine, some of them could perform well just by pure chance. So which is going to lead to overfitting, and basically this usually it is a bad idea to examine all the models. So unless we only have, I don't know, just a few variables. But if we have many variables, then there exist some systematic approaches to search through a subset of all possible models. So, and forward stepwise selection is one of them. Is probably the simplest one. So here we are going to begin with a model that contains no predictors, and then we are going to add predictors one by one. And every time we select the predictor that that is the best at the current step, so that leads to the greatest reduction in the error. So the algorithm works like this, right? So M0 is the model without predictors. So then M1 is a model with one predictor, and we choose the predictor that has the lowest mean squared error. And then M2 is constructed like this. So we begin with M1. So it has one predictor. So the number of remaining variables is p minus 1. And among them, we choose the one that if added to M1, then it leads to the lowest mean squared error. Then it's going to be M2. Then M3 is obtained from M2 by adding one more predictor, and so on and so forth, right? So when k is 0, we add 1 out of p variables as predictors. So we have p choices. So when k is 1, we have p minus 1 choice. When k is 2, we have p minus 2 choices, and so on, right? So the total number of models that we are going to train is p plus p minus 1 plus p minus 2, and so on, up to 1. Well, this is, of course, true if the number of observations is greater than the number of variables. Well, yeah. But what happens if the number of variables is bigger than the number of observations, right? So in that case, we're going to just stop earlier, right? So that because if the number of observations is bigger than the number of variables, it means that we cannot fit a linear model. So it is just simply impossible. All right, so we can just simply stop earlier. So either we stop at step p minus 1, or we can stop at n minus 1. All right, and then among all these sequence, in this sequence of models, M0, M1, and so on up to MP, or as I said, M, I guess should be n minus 1 probably. So maybe it should be n minus 2 here, I think. So we will pick the one that has, usually we just choose the one that has the lowest cross-validation error. But alternatively, you can use any one of our other criteria. So this is a so-called greedy algorithm, because at each step, we do not really think ahead, and we just select the model that that is looks to be the best at the current step. So here is how it works, right? So I'm going to compare the outcome of this forward stepwise procedure with the best subset procedure, right? So when k is 1, they produce the same thing, right? So when k is 2, so notice that in the forward stepwise procedure, so I sort it. So in every next step, I add one more variable to the previous, right? So rating, so then I add income. So, but in the best subset selection, so they're sorted alphabetically. So they're going to appear in a different order. but they're still the same. So in the next step, I have added student to the previously existing variables. So, and the best subset happens to be also the same, right? So income, rating, and student. But in the next step, they're different, right? So in the forward stepwise selection, I have added limit to the previously existing ones. But the best subset selection has this cards variable and does not have the rating variable. So it just happens that the best subset of 4 variables, well, it's just different. It does not include limit and includes cards instead. So sorry, it does not include rating and it includes cards instead. So, but somehow magically the next step is the same, right? So is again, so rating, income, student, limit, and cards. So, but my point being is that generally speaking, it's going to be the outcome of the forward stepwise selection is going to be different because it's just a different procedure. So the method of backward stepwise selection is very similar. So it begins with a model containing all predictors, and then we're going to remove them one by one in basically in the same fashion, right? So we begin with a model that has all P variables as predictors. Then among them, we pick the one that if we remove it, then we're going to have the lowest mean squared error. And then among the P minus 1, we're going to pick one that if we remove it, then we're going to have the lowest mean squared error. So the total number of models that we need to try is still P plus P minus 1 plus P minus 2 and so on, plus 1. In the end, we're going to have one predictor, and then we just remove it, and that's it, right? So this is also a greedy algorithm, so it has no advantage over forward stepwise selection in the sense that it doesn't really have, we do not look ahead when performing this. So the disadvantage of this backward stepwise selection is that it only works if the number of variables is not too large, because simply if P is bigger than n, we will not be able to start here, right? So this is the difference with the forward stepwise selection. So in forward stepwise selection, we can always start from at the model without predictors, and then we continue, and then if the number of predictors is too large, it just means that we will stop earlier. But here we are not even able to start. Well, sometimes people use hybrid approaches, something that goes like this. So we start with no variables, then we add variables one by one. But then at any point, we check the p-values. So we check statistical significance of all the variables that appear in our model. And then if at some point we have variables that are not statistically significant, then we start removing using the backward stepwise selection. And then once we removed enough variables, when everything is statistically significant, we start adding them again, and so on, right? So it goes back and forth. Now, this is just for your information, and again, this is something that you can do for your project that is outside of the course syllabus. So we are not really going to do this in our labs, and we are not going to do this in our midterm test. So it's just for your information. Okay, so this is the end of part 4 of the lecture.